We're now going to take a look at number 7. A research team at Cornell conducted a study showing that approximately 10% of all businessmen who wear ties wear them so tightly that they actually reduce blood flow to the brain, diminishing cerebral functions. At a board meeting of 20 businessmen, all of whom wear ties, what is the probability? And then in A through, I think it's D, we're going to be answering this question. So first, I want to identify this as a binomial experiment. We have a fixed number of trials because we're talking about at this board meeting, there are 20 people there. When we're looking at our A through D, we're looking for R successes out of those N trials. We have a probability of success. In this case, I could define success as the tie is too tight. So our probability of success is 0.1. So having that in mind, I'm going to take a look at the sheet that I gave you on Friday of calculator instructions for binomials. So if we take a look at this, it allows us to find various types of binomial probabilities. In looking at A says at least one tie is too tight. So that could be 1 to 20 ties are too tight if we're talking about at least one being too tight. Ways to do this using the formula would be to do something like find the probability of 0 ties being too tight and then subtract that from 1. But your calculator has a way that makes this easier. So when we look at this, I'm looking for the language that says at least. So I'm looking at number 4, at least, no fewer than or not less than. And this is the input that I'm going to put into my calculator. I'm going to pull up my calculator, and it's important that you do write down whatever your calculator input is so that I can give you partial credit if you happen to get it wrong. So I'm going to do 1 minus, and then to get to binom CDF, I do second vars. And binom CDF is letter B on my calculator. The trials, we have 20 trials. The probability of success is 0.1. And in this case, we're looking for R minus 1. My R is 1, so 1 minus 1 is 0. And this gives me the exact probability that I'm looking for. So earlier I had described finding the probability of 0 ties being too tight and subtracting that from 1. That's what I'm doing, but I'm doing all of that work on my calculator quickly without having to use the formula. So the probability that at least one tie is too tight is 87.8%. Now I'm going to take a look at part B. What about more than 2 ties are too tight? So my R in this case is 2, and when I look at that sheet, I'm looking for the language of more than. So that's number 5. And again, I'm going to write down exactly what my input on my calculator is going to be so that I can get any partial credit in case something goes wrong in my answer. So I'm going to go to my calculator, I'm going to do 1 minus, and then go second vars, and it's letter B. And notice I just clicked the alpha button, and then I'm going to click letter B right here on my calculator, and it takes me straight to binom CDF without me having to scroll through that long list. So still 20 trials, still a probability of 0.1, and in this case I'm going to put R in as it is. So my R was 2, paste, enter, and that gives me the probability that I'm looking for. So the probability that more than 2 ties are too tight is 32.3%. If I'm looking for the probability that no tie is too tight, I'm looking for R equals 0. And this is just an exact number that I'm looking for now. So if I'm looking for an exact number, I'm going to do number 1, And this one is, you'll notice, different from all the others because it's binomial PDF. Binomial PDF, you only use it when you're looking for the exact number. And so I'm going to do second bars, and I'm just going to show you. Binomial PDF is letter A, not letter B. So I've got 20 trials, a probability of success of 10%, and my R, in this case, is 0. So the probability that no tie is too tight is about 12.2%. And then the last one, at least 18 ties are not too tight. So notice the change in language here. All of the other ones have said are too tight, and I had identified my success as the tie is too tight. So if we're talking about at least 18 being not too tight, then we're talking about at most, 2 are too tight. Because if we have 18 that are not too tight, there are going to be 2 that are too tight. If we have 19 that are not too tight, we'll have 1 that's too tight. And if we have 20 that are not too tight, then we'll have 0 that are too tight. So we have at most 2 are too tight. So I'm looking at my R being 2. And I'm going to go back and look for at most. So that's number 2 on this list. So binomial CDF is second bars, and CDF is letter B. And you can see at the top here it should match CDF. So we have 20 trials, we have a probability of 10%, and our R value in this case is 2. So the probability that at least 18 ties are not too tight. Well, what did we find here? We found the probability that at most 2 ties are too tight, which is equivalent to at least 18 ties being not too tight. So that's about 67.7%.